um, we are going to discuss moments, and this is a new topic. And I would want to introduce moment and explain what is moment. The moment of a force measures the turning effect of the force on the body on which it is acting. The word turning effect, underline that. And of course, you'll be able to see that the moment of a force depends on the magnitude of the force and its distance from the axis of rotation. We are going to see what that means. And of most importance, it is very critical for all of us to note that the moment of a force F about a point P is the product of the magnitude of the force and the perpendicular distance of the line of action of the force from the point P. That may seem a bit confusing, but once we have a diagram like in example 1, of course you're talking about the force. The force, we have its units in newtons. We are talking about distance. The distance in meters. So we are talking about moments being the product of the two, and the units are N, M, Newton meters. We are so much going to depend on the magnitude of the force. We are so much going to look at the distance of the line of force to the point of rotation, and this one has to be perpendicular distance. Let us look at example 1. Find the moment of F about P. And the diagram just looks like this. We have, this is the F, and this is the distance, and this is point P. What you need to see is that this angle is 90 degrees. That means the line of force is perpendicular to, let's call this line OP, to line OP. OP is, the point P is called the point of rotation. So the moment as it is given in the formula is given by the force times the perpendicular distance. And this one is simply like that because the force is F in general and the distance is D. So the moment for this particular example is simply FD. But we will have to know, we know what this means is that if we keep rotating along the line of this force, this radius won't change. At this point it is there, another point the radius will be 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 there, until it forms kind of a circle. And that is the direction of the circle. So of most importance, direction is very, very important. So the moment of this particular force is FD, and the direction is clockwise, because it's rotating around or along point P in clockwise direction. Let us look at example 2. Let us look at example 2 so that we can exactly understand what is all about within moment, direction, and even this distance. Example 2 talks of what? Find the moment of F about P. Incidentally, you'll find that that is the direction of force, and that is the point P. And of one thing you would note is that the line of force and the line from the point of rotation to the line of force, they do not make 90 degrees. So this distance is not perpendicular. So we must always look for the perpendicular distance between the point of rotation to the line of force. And fair enough, that is the distance we are talking about. And if this is D, and we are told this is theta, of course here we have to use the trigonometric ratios and understand that as much as we have the force, we don't have this perpendicular distance. So we will have to calculate it. And as far as theta is concerned, this is the opposite direction, the opposite side of theta, and this is the hypotenuse, since it is the hypotenuse of the entire triangle. So we can start by saying the sine theta, as we know, is given by opposite. Let's talk about y, opposite y all over the hypotenuse, which is d. But we are looking for y. We need to make y the subject of the formula, which is y is equals to d sine theta. So the moment, now that we have the perpendicular distance, the moment is given by f d sine theta. But we have not written the direction. So again, if this force continues to push this way, this radius will never change. It won't change. At this point it will be there. At this point it will be there. So it will kind of be forming a circle, and the direction, as you can see, is anti-clockwise. The moment is f d sine theta anti-clockwise. Okay?